Hey guys, Joe Pye here, Advanced Innovations. Welcome back to my shop. You know, we all have little bucket list items that we want to knock off someday, right? Everybody's got one of those projects that they say, I want to make one of those someday. Well, today is a someday for me. I really should be doing something else, but no, I want to check something off the list while these machines are still plugged in. So I'm going to grab a piece of stock and I'm going to start hacking away. I'm not going to tell you what I'm going to make, but it's a fun little project. And if you guess what it is sometime during the course of this video, take a look at the timestamp on the video and leave me a comment and say, ha, got it. So let's get over to the stock rack, pull some material, hit the mill, have at it. Okay, for those of you that have never done this, set your digital caliper to the length that you want and zero it. Close the jaws and make sure that nothing shifted when you zeroed it. Now you have a preset zero standard length. When you measure your part, the value on the readout will be how much you need to remove or how much you've missed it by. All right, guys, here's a shop gem for you. I want to find the center of this piece of material right here. That is 1 inch square. Actually, it's like 1 inch 005 square-ish. But for what I'm doing, this is fine. Now, instead of tramming both sides of this, or trying to tram both sides of that, and being a little frustrated in the effort, watch this. You're going to scratch your head and go, what? I had no idea. Well, check this out. You're going to like this one. I guarantee you're going to like this one. This is a piece of 1 inch diameter round stock. When I tram either side of this round stock, it is going to put me on the same center as if I were holding a piece of square stock. Why is that, you say? Well, because the distance from the top slanted surface to the center line and the distance from the bottom slanted surface to the center line is 500 both ways. Well, you know, guess what? That's exactly the same, 500 here to here, 500 here to here. Put you on center with the 1 inch square stock. Bet you didn't know that. Good trick. Zero, zero on both faces. Actually, 2 before, but it's the same on both faces. So that's fine. Put the real piece in, see what that looks like. Now, if that philosophy is true, the machine should be centered right on the edge of this part. Piece of cake. Okay guys, at this stage of the game we have a 1-inch square piece of aluminum, 2 inches 625 long, with a 1/4 inch hole through the edges at 45 degrees, completely through. Next step, we're going to pop a couple of holes in the outside, and then we'll get to milling it. Make something out of this. Setup for the next step in this operation, or the next several steps in this operation, is pretty easy. Make sure you have a bump stop on one end of your stock, find a 0, find a 0, move to the center of the part, and set that as your 0 also. So technically that little point right there is your 0, 0. Simple. Let's drill some holes. Ultimately, I want this to be a 5/8 hole on the end, but I'm going to start with a 1/2 inch, then I'm going to plunge it with an end mill. 2 holes, one here, the other one 90 degrees opposed. So I'm going to take the part out, flip it, and rotate it 90 degrees. Do the second one. Okay guys, bear in mind that the dimensions that I'm giving you are for your convenience if you want to duplicate what I'm making. I'm going to use a 4-flute 5/8 diameter high-speed steel end mill to open these holes up. Could be a drilled hole. It really doesn't matter, but I know that 5/8 is going to perform well. It's going to squeal a little bit. I can pretty much guarantee that, so hold your ears on this one. Okay, there you go. Looks an awful lot like a vice stop, doesn't it? But it's not. All right, let's change the size of the cutter. Take some more material off of this. All right, guys, here's a handy little tip for those of you with digital readouts with an absolute and an incremental option on it. Right now, on my y-axis, I am on the center line of that 1-inch square block, which means I'm 500 either way or 502 either way, depending on the nature of the material. I am also 500 in from the end face. I have a 7/16 end mill in there right now, 436 it measured. So I'm going to return this to 0, 0 after I unlock my table. Boy, if you ever shot a machining video, you know it's a pain in the neck with a tripod and a boom. Anyway, right now the cutter is directly over the end of the part. What I want to do, I want to offset. I'm going to go to the incremental now. Watch this change over to incremental. I'm going to zero them both out. So the absolute and the incremental, toggle back and forth, are the same. I'm going to offset the X so that the cutter edge is now the 0. So that's what, 217.5? Okay, 435. I'm going to call that 0. What is this going to do for me, you may ask? Well, the dimension on the print is 875. I can now move the part 875 on the digital and get 875 on the part. If you were to do that in absolute, you would blow your dimension by the radius of your cutter. It's going to be a little easier to understand when you actually see it. So let's reposition the camera and explain it. In the absolute mode, this is the 0, 0 setting for the table, for the part. When I switched over to incremental and offset the radius of the cutter and zeroed it again, my incremental position is now 0, 0. If I want to cut a step in the end of this part at a given length, I can do that by watching the digital now move to that specific dimension. Makes it a lot easier to pay attention to steps and such. But, big but here, I like big butts and cannot lie. Do not forget to change it back when you're done doing this, or you could really get yourself in trouble. So do not forget to change it back. All right, let's deck this off and do a couple of cuts here, get her going. We're going to cut a step on the end, 875 in, 375 deep, on both sides, on both ends. These are 4 identical cuts. We're going to be flipping the part in between cuts. All right. I'm going to set the depth first. Naturally, this is a very accelerated segment. That is a 7/16 diameter 2-flute carbide end mill running at about 1650 RPM. And I want to pick the piece out of the vise and take it out of frame for a second. I'm wiping the outside surfaces with a flat file so that it sits the way it should in the jaws and registers on the parallels as I hope it would. Okay, now we're going to handle this particular operation a little differently than we handled this end. The cutter is now 375 down from the top. It is zeroed out. This is 875. I'm going to take the cutter now and I'm going to blend this face all the way through at this depth on both sides. So this is now going to be a rib going straight down the back, and with any kind of luck, it'll blend here and blend here. So let's see what happens. I'm going to lower the table 5 thousandths so I have a cleanup pass when I come back around. So there you go, down 5. Knock all this material off on both sides, leave a center rib. I'm going to remove the bulk of this material by eye with little or no care for where the actual cut is. Of course, I don't want to crash into anything. And I want to get close. These vertical surfaces on the end, I'm going to put some Sharpie marker on it, and I'm just going to wiggle the table back and forth until I start to see that Sharpie go away. You'll see the blend. There it is. And I'll do the same thing in the back. Be nice if I had a small TV camera where I could see that, but I'm actually bent over looking at it from behind. All right, at this point, you got to keep in mind that the locating surfaces that used to be on your parallels are now gone. So you're going to have to adjust the height of the parallel to maintain some degree of clearance with this part. I'm going to say you got to come up with the parallels 3/8 of an inch, since that's what was taken off of this side. All right, coming up on the last stop, this is what you should have. Last operation, we put back in the machine this way, bumped. We're going to remove these 2 ribs there. Part was already in there. I'm just removing the excess material. Reestablish the height of the cutter to the deck. Do the exact same thing we did on the last operation. Take these chunks on the sides, even with this, even with that. Let's do it. This flip side is done exactly the same way that the other side was done, with the exception of the new 0 height. With the taller parallels, I had to reestablish the 0 on that. You'll see me take a dust cut on the Sharpie marker right there and watch the Sharpie go away. There it is. And we're going to blend the back until the Sharpie goes away once again, that you can't see. It's off camera. Come around, freehand it, make the front blend, boom, done. Hey guys, any ideas? Couple more cutter changes and away we go. Let's do it. Okay, next step in the process, I'm using a 3/16 diameter cutter. Center of the hole is 500 from this end. I'm going to go 1 inch 250 from that hole, actually from the end in, and intersect those cross holes right there. Tangent to the inside of the 625. So this is going to be tedious. I'm probably going to leave a bunch of little scallop marks on here. I can live with that. Let's do it. I have to make 2 identical channels in this part, one on the front, one on the back. And I'm using a piece of paper right there to register where the material, or where the cutter is in relation to the material. And I do not want to bury the entire cutter like that because of the way it's going to pull into the material. It would chop it up pretty good. I will take a full depth, full pass back to the 500 center on that end hole. That end hole is a 625, a 5/8 diameter hole in the end. And the same thing, paper trick on the other side. When the cutter cuts the paper, you are close enough. But once you're there, don't move the table. Now this cutter is going to have a tendency to walk in a different direction on either side, strictly because of the rotation of the cutter. All right, any guesses yet? Should be pretty obvious. Coming around, here we go. The second side is done exactly the same way as the first side, with the exception that I'm doing the back before I do the front. There is a reason for this. I want the front to be the most visible cut because I think it's the most important cut. Also going to take off the little nubs left over from the 625 cutter. You may have seen me do that in a couple of the previous steps. Going to run the cutter down till it just nips the front, and away we go. I tell you, that trick with the paper works really well. Some people say use a cigarette paper, but a cigarette paper is only 1/1000th of an inch thick, and it gets you a little too close. Use a piece of standard white paper, 3.5 thou thick, gives you a little bit more wiggle room. And boom. Yep. Now you get to clean up the ends. There we go. The one thing that may not be immediately apparent between these two video segments is the fact that I have a piece of aluminum wire securing the loose end of the link in the next shot. That is stretched across the table, connected to a hard stop to keep it from ending terribly. Well, there you have it. A functional 2-link chain made from a solid block. You can make as many links as you want. Depends on how much math you want to do and how creative you get with your setups. When it starts to flop around, do not let it get pulled back into the cutter. That would not end well. I'm going to step off camera here for a second, round some of this stuff off, make this look a little bit more like a chain. And I'll be back in a second. Now, you can get as carried away with this as you want to, as time permits, which I don't have. So as you're sanding on this, make sure you keep a cup of water local because it's going to get warm. Man, I've always wanted to do that. I finally did it. There you go. Be right back. Okay, well, here you go. This is after a couple of minutes with the sander. A little bit of Scotch-Brite on the edges. Blasted the whole assembly when I was done. And that is just something I've always wanted to do. It came out okay, I guess. You can spend as much time as you want to. If you want to do this on a rotary table as a secondary operation, I'm sure you could get it spot on and put some really nice chamfers on this. Let's unlock that focus for a second. There we go. The finish is a number 6 glass bead at about 60 psi in my sandblaster. And then I wash it with Palmolive to get the embedded glass media out of the material because it will stick. That's all I got for you guys. I hope that you like that. I will figure out a way to put the plans, probably going to PDF them and put them on my website. Just go ahead and download them. Or if you have a problem with that, I'll send you a copy directly. Just shoot me a link through the website contact page. And off we go. I hope you enjoyed that. I certainly did. This was about a 5-hour project for me. Setting up the camera, getting the different camera angles, doing the filing and setup and stuff off screen. But one day, there it is. Always wanted to do it. Now I did it. Thank you very much for tuning in. A very big special thank you very much to everyone that has stopped by the GoFundMe site and contributed to the Move Fund. It has really made a huge difference, and I can't tell you how much I appreciate it, guys. Thank you all very much. So, wherever you are in the world, I hope you're well, happy, and safe. All of the above. I am Joe Pye at Advanced Innovations in Austin, Texas. I'm out.